Chapter 7 Inverters and Charge Controllers. This chapter examines both the inverter and the charge controller, and seek to make a verdict on which is the better option for you. Both the charge controller and the inverter perform a similar role as they sit between the solar system and the rest of the grid, but they go about their work in markedly different ways. The solar inverter. What is it? The solar inverter works to convert solar power to 240-volt AC directly. To put it simply, with an inverter, when the sun is shining outside, and the solar panel is picking up its energy, you can use the power produced in your house directly from the panels without having to cycle your batteries. To charge your batteries, you need to pair the battery up with a battery inverter that is compatible. This battery-battery inverter pairing is referred to as AC coupling, seeing as the link is with AC electricity in this scheme. The charge controller. What is it? The charge controller works to take DC solar power produced from the solar panels and directs it to the batteries for charging. The primary function of the charge controller is to regulate the power that gets to the battery, so as not to overcharge them and risk damaging them. This regulatory function is why some people refer to them as regulators. The power thus stays in DC format all the way from the solar panels to your batteries. It only goes through 240-volt AC conversion when the time to use it in your house is nigh. This conversion is made possible via the battery inverter we discussed above. This conversion coupling is called DC coupling, seeing as the DC solar panels get coupled with the DC charge controller, with the ultimate goal of charging up the batteries. Where does the difference lie? The difference is that while the solar inverter is AC coupled, the charge controller is DC coupled. Which one presents the better option? There are many reasons as to why anyone would prefer to opt for one and not the other, and the argument can be made that it is healthy to have both options in your system. Here is the thing though: DC-coupled systems tend to be more cost-effective, and significantly so, for small, domestic standalone systems. AC-coupled systems boast of the same cost-effectiveness when it comes to larger systems. If your solar system is small-sized and only powers your house, consider the former. However, if you intend to have a more extensive domestic system, the latter is the better option.